This is problem number 3 on the practice problems for test number 2. Surveyors wanted to estimate the area of a lake. To do so, at various intervals, they measured the distance across the lake. X below gives the distance in kilometers measured eastward from the westernmost point on the lake shore. F of X gives the north-south measurement of the lake for that value of X. So I'm going to draw a lake that probably has little bearing on reality, but just to give us a sense of what's going on here. So X is the distance measured eastward from the westernmost point. So from the westernmost point, maybe right there. And then, for example, if we go 1 kilometer eastward, then the north-south distance at that point is 3. So that's this data point right here. And so you have lots of data as this lake goes from left to right. And continuing with the directions here, it says note that the subintervals are not of consistent width. That is, going from 0 to 1 is a change of 1, but going from 1 to 4 is a change of 3, and then going from there to 8 is a change of 4. So not of consistent width. We'll see how that comes into play later. So part I, give a left-hand estimate of the area of the lake. So left-hand estimate means you're going to use the left-hand point in each interval. So if I'm looking, for example, between 0 and 1, I will use the left-hand point to dictate the height of that rectangle. So the height in that case is 5. The area of the first rectangle is a height of 5 and a length of, and here's the distance, it's 0 to 1 is 1. Plus, then we'll look at the second rectangle. We'll do this one in green. So now using the left hand out of those 2 points, left hand point is 3 times, and now the width of this rectangle, it goes from 1 to 4, that's also 3. Do the next one here in black, 4 to 8, and then 1 and 6. So the left hand point of 1 and 6 is a 1 times, and then the width between 4 and 8, that's a difference of 4. And so we'll just write down the last couple of answers here. Next interval, we pick the left-hand number as 6, and the width is 9 minus 8, or 1. And then finally, the left-hand point of the last interval between 4 and 0 is 4. And then the width is from 9 to 10, also 1. So we crunch all these numbers together, and we get 28 square kilometers in this case. Part II, or part 2 down below, estimate the area of the lake using the trapezoid rule. Note that you can't average the left-hand and right-hand estimates because the subintervals are not of equal width. So in class, we did see a formula that said that if you want to find the trapezoid estimate for n trapezoids, it was a simple matter of averaging the left-hand estimate with n rectangles and the right-hand estimate with n rectangles. So add them and divide by 2. Unfortunately, this is only valid if the intervals are of consistent width. And as we've seen here, the first interval has a width of 1, but the next interval has a width of 3, and that's a width of 4. So we can't just average the left and right hand estimates. It should be over 2. So all we can do is actually draw a trapezoid. So in order to answer this question, we need to know the formula for the area of a trapezoid. It's half the height times the sum of the bases, where the bases are the parallel sides. So let's go ahead and do that here. So looking in the first interval, that's the one in red here, we've got 0 to 1. So the height is just the difference between those two numbers. So the first height is a 1. And then we're supposed to take half of that and then multiply by the sum of the bases. The bases are the parallel sides, which are the 5 and the 3 in this case. So for us, it's half of the first height is a 1, and the two bases are 5 and 3 plus. And then we're going to do another trapezoid. And as I do this problem, I realize that in my head I've got a picture of some data, and maybe that's useful to draw. So if I wanted to give a very quick sketch of just the first few points, so 0, 5. Is up here, and the next one is a 1, 3, And then just one more is enough, 4, 1. So that's way out here. So the trapezoids that we're envisioning are, let's see, so in the first interval, we're going between 0 and 1, and the trapezoid is that. So that's what we're trying to find the area of. And in the next interval from 1 to 4, the trapezoid is this. So when we found half the height and multiplied by the sum of the bases, we found half the height. The height right here is this distance, that distance right there, which is a 1. And then the sum of the bases were 5 and 3. And so now we're about to do the same thing, but for the purple trapezoid, half the height is this distance here, 4 minus 1, and then times the sum of the bases, 3 and 1. So we'll do this in purple down below. Half of the height is 3, times the sum of the bases, 3 plus 1, plus, and then we'll just write out the last few trapezoids. You can pause the video here if you want to try to calculate this on your own and then come back. And so if we crunch all this stuff together, and if I did my arithmetic right, 31 is our estimate for the area of the lake, 31 square kilometers. Okay, last part 3, why can't you use the midpoint rule for this problem? So in order to use midpoint rectangles, we need to have information about midpoints. So for example, if I'm looking in that first interval from 0 to 1, the midpoint is at 1/2, but I have absolutely no information about the lake 1/2 kilometer in. So then if I want to have any chance at this working, I better skip over a point and cross my fingers and hope that it's the midpoint of the 2 points that are surrounding it. And unfortunately, 0 and 4, the midpoint is at 2, and we have only information about 1. If this did happen to be a 2, then maybe we could keep going. We'd look at the next interval, skipping over 1. 4 to 9, the midpoint is what, 6.5. Unfortunately, that's not 6.5. Then I really wouldn't know what to do. I don't even have like the right number of points here to think about having midpoints. So for a lot of reasons, we can't find a midpoint approximation. I've just written here that we don't have information about the lake at the midpoint of the first and third points, for example. X equals 0 and x equals 4, we said have a midpoint at 2.